In this work, we introduce a design study on voice-based interaction for immersive network visualization and analysis. Visual investigation of network structure is fundamental in network analysis. Immersive network visualization has the potential to enhance visual investigation by providing a more intuitive and engaging way to explore complex network data. Despite many efforts in designing multimodal interactions for immersive network visualization, such as gesture and eye gaze, the usability of immersive analysis systems remain low, limiting their adoption in practice. With the advancement of large language models, voice-based interaction has the potential to enhance the usability of immersive analysis systems by providing a more natural and efficient way to interact with the system. This motivates us to investigate the advantages and challenges of using voice as the primary input modality for immersive network visualization and analysis. We design and develop a system supporting network authoring commands, such as selection, setting colors, shapes, and statistical queries. Next, we demonstrate the system with an illustrative use case of analyzing a social network. The dataset contains a bully friendship network in which each node represents a student and each edge represents a relationship between students, which can be either aggression or friendship. Node attributes include gender, grade level, smoker and drinker status, and GPA. First, the main graph shows the overall structure of the network without additional visual encodings. The user can use voice commands to select nodes, set visual encodings, and ask for statistical queries. In this example, the user first say, select only smoker nodes. A subgraph is created in front of the user, showing only the smoker nodes. The user can walk around the subgraph to see the details. The user can also say color nodes in blue to change the node color, and color aggression links in pink and friendship links in purple to change the edge color. The system also supports shapes. For example, saying shape nodes by gender will change the node shape automatically. We conducted a user study on 10 participants to evaluate the usability of the system and identify the advantages and challenges of using voice-based interaction. Participants conducted 3 realistic tasks, including investigating centrality and grade distribution, investigating bullying within or across behavioral groups, and investigating patterns on isolation, gender, and victimization. Our findings suggest that voice-based interaction significantly lowers the barrier to entry by simplifying the interaction process and allows users to focus more on the analysis task. Participants tend to prefer voice interactions over controller and keyboard interactions, especially for those unfamiliar with immersive systems. We also found that participants take several social interactions into account that affects adoption of voice-based interaction. Based on the findings, we discussed the role of usability in improving VR adoption and the benefits of voice-based interactions for improving interaction fluidity, simplifying operations, while supporting complex analysis tasks. Together with existing guidelines for voice-based interfaces, these findings suggest that effective immersive analytics systems should balance voice interaction with supportive visual and embodied interactions, enabling users to fluidly navigate analytical tasks.